So let's look into the proof of ASA congruency rule. So ASA stands for angle, side and angle, and this side has to be an included side. So this is your statement which tells that two triangles are congruent if two angles and included side of one triangle is same as the other triangle. So the diagram would be something like this. So try to draw two congruent triangles itself. Copy, paste, and don't draw equilateral triangle. Okay, I try not to draw equilateral triangle. I hope this doesn't look like one. So let's consider triangle ABC, which is congruent to DEF. We need to prove that. So here the angle B is equal to angle E, angle C is equal to angle F, and included side BC is equal to EF. Okay, so we need to talk about this. Let's consider triangles ABC and DEF, where angle B is equal to angle E, angle C is equal to angle F, and BC is equal to EF. So next thing is to prove. What is that we need to prove? Triangle ABC is congruent to triangle DEF. So the fund of this theorem is that if we have an angle, a side and an angle, and this side being included side, if this is satisfied, this condition is satisfied, then these two triangles are congruent. That's the theorem. Two angles and the included side, if they are equal, then these two triangles are congruent. So that's the whole idea. You don't need more information to tell that these two triangles are congruent. If we have an angle and an included side and another angle, then these two triangles are congruent. That's the basic funda. So how do you prove it? We need to do it case by case. So the first case is AB if AB is equal to DE. See, what we are going to do is we're going to fix, okay, you know, these two angles are equal. I mean, these two pairs of angles are equal and these sides are equal, but we don't know much about other sides. So either AB, the side AB has to be bigger than DE, equal to or smaller than. Again, we say, let's say this is 30 degree and this is 45 degree. This is 30 and this is 45. That is fixed. If say this is 15 centimeter, this has to be 15 centimeter. So that is the initial condition. Now we don't know about these two sides and this angle. Obviously this angle is equal to this angle. That's not an issue. But what about the sides? Well, as of now, we are not yet clear. You know, how are these two sides related to the other two sides? Well, either AB has to be greater than DE or equal to, if not lesser than. Those are the three possibilities. Okay, so we're going to cover all the three possibilities. The first being if AB is equal to DE. So that's what we're going to start off with. Say we have the side, these two sides are equal, then what happens? So let's have a look at that. Let me erase all of this. Yeah, the values are only for your understanding. So let me erase this off. Okay, now case 1. So when AB is equal to DE, if these two sides are equal, what happens? Well, we have a side and another side and the included angle of this two triangle to be equal, then these two triangles are congruent. I'll explain it over here. Okay, if this is true, but also it's given that angle B is equal to angle E, and we have BC is equal to EF. Thus, by SAS congruency, triangle ABC is congruent to triangle DEF. Okay, so first case, if it's true, then these two triangles have to be congruent. Okay, so the first case is quite simple. From the second case, second and third is actually one and the same. So if you get confused, you will get confused over here. If not, it's not that hard. Then the case is if AB is greater than DE. Okay, so I'll explain it this way. So you might have to end up drawing one more diagram if you have time. I think you should. Okay, this is an equilateral triangle. I don't prefer using that. So copy paste itself. So we have triangle ABC DEF. Yes, B is equal to E and C is equal to F. Now we are telling that AB is greater than DE. Say this is D is around, again it's only for understanding, 12 centimeters. This is around 15 centimeters. So AB is greater than DE. We are assuming it so. So what we can do is, I can do a construction wherein from point C, I will take a point P wherein PB is 12 centimeter. Okay, so this is 12 centimeter from here to here. Right? See, the point is that since AB is greater than DE as per our assumption, means we will have a point on AB, sorry, wherein DE will be equal to the other length. So that point is your P. So PB is equal to DE. So we need to write that. Let's consider point P on AB such that PB is equal to DE. Then we will also join PC. Now consider triangle PBC and triangle DEF. We have PB is equal to DE and also we have angle B is equal to angle E. Okay, it's already given. And BC is equal to EF. This is also given. Right? So again, with SAS, these two triangles are same. Thus by SAS congruency, triangle PBC is congruent to triangle DEF. Okay, so we just proved that this particular triangle is congruent to this particular triangle. So what can I tell about angle BCP? Well, this angle should be equal to angle EFD, this angle. So those triangles are equal. How? By CPCT. But we know that angle EFD is equal to angle BCA. Right? This is given. This is considered. Have a look. BCA is equal to EFD. So from this to what can you tell? This implies angle BCA is equal to angle BCP, right? EFT is same over here, so this quantity has to be equal to this quantity. That's what I have written. Okay, so if these two are equal, what does it mean? This is possible only if A and P are one and the same. This is the confusing part. Have a look. Just have a look for a second. Okay. So this scenario is possible wherein we have BCP being equal to BCA. This is only possible if this is only possible if P, okay, I'll write it over here, P coincides with A. That is, P and A are one and the same. So basically we are indirectly telling that therefore triangle ABC is congruent to triangle DEF. Now the last statement, okay, so last case, that is, sorry, let me write it over here, neat. Case 3, DE can be bigger than AB. That's the third case. If not, AB is smaller than DE, right? So this is case 3. So how do we prove it? Similarly, all you have to do is construct a point P over here. So this length will be bigger than this, so consider point P and prove those show to triangle and this triangle is congruent, and same procedure. Okay, so all you have to do right over here is, you don't see, it's a similar set of steps. So the math allows you guys to write a statement and you tell, okay, we have the same thing, similar thing, so we can prove it the same way, and so we have proved it, right? We can write in this way. We can choose a point M or P on DE. Okay, so this is DE. We can consider point M or P, like how we consider P over here, we can consider P over there, such that PE is equal to AB. PE is equal to AB. Okay, then we'll tell by repeating a similar argument as above, or as in case 2, as in case 2, we can conclude that AB is equal to DE, or D, okay, PE is equal to DE, which in turn is equal to AB, and thus triangle ABC is congruent to triangle DEF. Okay, so this is your proof. That's it. Very simple proof, right? So I'll repeat the entire thing. So we are looking at ASA congruency. Okay, so we are looking at ASA congruency. So the congruency tells that if you have angle, included side and an angle being equal to between two triangles, then they are congruent. So say this is your first triangle, and the second triangle will obviously look the same because they are congruent. So we can have A P and C, and this is E, F and G. So these two triangles are congruent. So these two sides are equal, so on and so forth. So this is given. We are confused about the sides. The angles are equal, but we don't know about the sides. So if you are able to somehow figure out, if AC is equal to GE or any of the sides, then by SAS we are able to prove that these two triangles are congruent. So there are three possibilities between AC and GE, right? AC can be equal to GE, AC can be greater than GE, or AC can be lesser than GE. Okay? The corresponding sides can be either equal, greater, or lesser. Does it make sense? So this can be 10, this can be 10, or this can be 8, or this can be 12. We don't know. So taking up different cases, we proved that these two triangles have to be congruent. So if you are able to cover all these three cases, means we are done with the proof. Okay, I hope it made sense, right? So the cases is quite simple. The first case is very easy. The second case is the one which is confusing for many. Okay, if not, only this part is confusing, right? Only this part. If not, everything else is quite simple. A simple construction and so on and so forth, and you're done. Third case is a statement telling that we can prove on a same line wherein we consider point P on DE, so that P is equal to AB, and by repeating a similar argument as in case 2, so we can write this and we are done, right? Very simple, straightforward proof at the start, confusing in few lines in the middle. If not, it's very simple. So please pause, have a look. If any doubt, let us know.